All right, good morning. This is e-learning day for March 30th for Math 1. So today we're going to start talking about congruent triangle postulates, meaning ways of proving triangles are congruent. Remember that we said that congruent means that they are the same size triangles. Okay, so we're going to start with this packet that I gave you. Alright, so it says Geometry Smart Packet, Triangle Proofs. Alright, again, don't worry about what these letters represent. We're going to get to those here in a second. Okay, so we're starting with these notes. Alright, so I want you to skip over to this page where they start talking about the postulates for proving triangles congruent. Okay, so one way we can prove triangles congruent is if both triangles have three sets of congruent corresponding sides. Okay, so now, if you recall, we talked about these tick marks telling you like what all is congruent. So again, with a single tick mark here on side AB, and the same tick mark here on side DE from the other triangle, we know that those sides are congruent. Got the double tick mark on BC, the double tick mark on EF, so we know that BC and EF are congruent. And you notice with the third side, these two also have the same tick marks. Alright, so if you know that both triangles have three sets of congruent corresponding sides, alright, then you know they are congruent by the SSS postulate, meaning all three sides, side, alright, are all matching up. Okay, so that's one way to prove triangles congruent, if you have three sets of corresponding sides. Okay, the next postulate here is the side angle side postulate. So again, you take a look at the way these two triangles are marked up. Right? You have one set of sides, one set of angles, and a second set of sides. Okay. Right? So this is all you need to be able to prove these two triangles congruent by the SAS postulate, the side angle side postulate. Two sides and an angle in between. So what's really important for SAS is that the angle in between the two sides is the one that is marked congruent. Right? Here's your two sides. Here's the angle in between. Alright, so it's side, angle, side. Side, angle, side. How these two triangles are going to be proven congruent by the SAS postulate. Now, I want you to keep in mind, one of the things with these postulates is it's telling us that we don't really need everything to be marked up, right? With the SSS postulate, you notice that we didn't have any angles tick marked. Okay, the SSS postulate says, hey, you don't need angles to be marked up congruent. If you have three sets of corresponding sides congruent, that's enough to say that these two triangles are exactly the same. Same thing with SAS. Right? Here we only have two sides congruent. We don't need that third side. As long as we have the angle in between the two sides marked up, we know that, hey, this is enough to prove these two triangles congruent by this SAS postulate. Okay? Next postulate is the angle side angle postulate, ASA. Alright? So let's first take a look. So angle A and angle D are marked up with the same markings. Side AB and side DE have the same mark. And angle B and angle E have the same tick mark. Okay. So Doesn't matter what all the other sides are marked up or not marked up. Doesn't matter about that other angle. As if you have two angles and a side in between, right? Here's angle, side, angle. Two angles and a side in between, marked up from both triangles. That's enough to say that these two triangles are congruent. And the reason would be the ASA postulate. Next postulate is the angle-side postulate. All right, so again, we have two sets of angles. Angle A and angle D are congruent. Angle B and angle E are congruent. And we have one side congruent from each. Okay, so now you notice with this one, for angle-side, the side that's tick marked is not in between the two angles, sorry. Okay. So as long as you have angle-side, angle-side, where the side is not in between, that's enough to say that these two triangles are congruent by the AAS postulate. Okay, so again, we're going to get some more practice here with the homework in a bit. I want you to skip over to this page, because this page has some, as it says here, common properties, definitions, or theorems for triangles that we're going to need to know to help us prove these triangles congruent. Okay, so the first thing we're going to look at here is the reflexive property. So this is the reflexive property when the triangles have an angle or side in common. So here you see that we have two triangles in this picture, two smaller triangles, all right, where these two triangles share this side. Okay. So we can say, because these two triangles share a side, we know that, hey, side HJ from this triangle is the exact same measurement as a side HJ from the triangle off to the right, because they share that same side. Reflexive property. Okay. Another common property we need to know, or definition, is the definition of a midpoint. Alright, when you have, for example here, point J. If I tell you that point J is the midpoint of side KI, by definition of midpoint, right, which is then the middle point, you know that KJ and JI are the exact same length. Right? So if you know for a fact that J is a midpoint, and you know that these two sides on either side of J are the exact same length. Alright, next property here is the vertical angle property. Alright, so here we see two triangles. Alright, but here we're going to be focusing on these angles that are marked up in between here. Right? Alright, angles like these, right, that are across from each other, are congruent because they're called vertical angles. Alright, the way you can identify vertical angles is this. If you can make an X, right, see if you notice my tracer here, BE and AD make this big giant X. Alright, so if you can make an X, know that the angles inside the middle of the X here, those are vertical angles, and those angles will always be congruent. You can tick mark them as being congruent. Now, these aren't tick marked here, but if I wanted to, I can talk about this angle right here and an angle across from it on the other side of the X as also being congruent. Okay? But because we're going to be talking about triangles, we're going to be interested in the angles that are inside these two triangles with respect to the X. Okay, so these are vertical angles. Alright, and I think, yeah, that's the last one I want to talk about here today. Alright, so we're going to move on to the note sheet. Okay, so let's get the note sheet up here. Alright, so here we're going to practice using those postulates we talked about. So we are looking to zoom in here a little bit. Alright, so we want to determine if the two triangles are congruent. So again, based off of the markings, can we use any of those postulates? So again, we're going to remind ourselves, right, the postulates that we're going to be using are either side, 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 angle, side, angle, side, angle, or angle, angle, side. Okay, so these are our four choices. Alright. So again, it says determine if the two triangles are congruent. If they are, state how you know. So take a look at number 1, and we see that we have 3 sets of sides tick mark, and we see that with the other triangle it had the same set of tick marks. Alright, and so because we have those markings, we know that these two triangles are congruent. So we're going to say yes, they are congruent by the side, side, side postulate. Right, because they have all 3 sets of sides tick marked to be congruent. Number 2, take a look at the tick marks. Right, so I have 1 angle from each, right, same tick mark, a second angle from each, and a third angle from each. Right. So based off the markings, I have 3 sets of angles. Right. But you notice that none of our postulates has 3 angles, or AAA. Right. So because we don't have an AA postulate, we're going to say no, these two triangles are not congruent. Right? There is no AAA. There is no angle, angle, angle postulate. Alright, moving on to 3. Now we're looking at the tick marks. We see 1 angle from each, a side from each, and a second angle from each. Alright, and because the side is in between the 2 angles, here's the side again, tick mark, in between the 2 angles, we know that we have a postulate for that, and that is angle, side, angle. So we're going to say yes by angle, side, angle. Right? Angle, side, angle. Number 4, we got double tick mark on this side, got a double here, got an angle marked up in each, got a triple tick mark on one side, same marking over here. So we have the same markings for both triangles. So let's make sure the arrangement is proper. So I have a side, angle, side. Side, angle, side. And SAS is one of the postulates, so we're going to say yes, these two triangles are congruent by side, angle, side. Okay. Number 5. So here's where we're going to use those special properties. So we have 1 angle from each. We have 1 side from each. Okay, so that's all we got. So just 1 angle and 1 side. That is not enough to prove these two triangles congruent. But because we have this big old X, again, we know that vertical angles could be something that we could use, and we're going to use it. So I'm going to mark up these 2 angles in here as being congruent. Again, they are vertical angles because they make a big old X. Angles that are across from each other are congruent. So with that marking, I have angle, angle, side. Angle, angle, side. So we're going to say yes by the AAS postulate. Okay, moving on, number 6. I got 2 sets of sides marked up. That's 2 S's. Okay, so again, we cannot prove it congruent by SS alone. But we have, again, these vertical angles here. You can mark that up. But you notice again with the way that the tick marks are, right, they do not follow the same order. Right? There is no SSA, right? They don't match up, so they are not congruent. Okay, we're going to finish up with this last one here. They share this side. Congruent. Angle, angle, side is how they are congruent. Alright, so we're going to continue this tomorrow, do the homework, and I'll see you guys tomorrow.